Okay, let's get into the next section, which is 7.3, special exponential functions. And the first thing that we are going to look for in this case is the um, function e. So e is what is known as the exponential function, and it's an irrational number that is approximately 2.7182818, and then it continues on forever. An irrational number is just something that has decimals that continue on forever, nothing repeated, nothing that you can convert into a fraction or anything like that. So, for example, pi is irrational because it continues on forever. However, 1/3 is rational because we can write it as a fraction, so it just continues on, but it can be written as a fraction. So anything that can be written as a fraction is rational. Anything that cannot be written as a fraction is irrational. So e is equal to 1 plus 1 over n to the n power. That should look really familiar because that's similar to the interest in compounding. When we did that, we had a few other extra things there, but that's what E is defined as, and it continues to grow, or n continues to grow without bound. What that means is that n grows forever. So n could be, gets closer and closer to infinity, and as that happens, then we have the value of E in that case. So you can look at it by, plugging in 10 or 10,000 or 1 million, and you'll see how it gets closer and closer to this particular number. So continuous compounding is A equals P. Remember, P is the principal, E to the RT. R is the interest rate. T is the amount of time, usually in years. And so what continuous compounding means is that when you put money into your bank account, it starts gaining interest right away. So, and I don't want to say seconds because it's even smaller than that, but it immediately starts getting interest as you go through. So continuous compounding is definitely going to be better than monthly compounding or yearly compounding or anything like that, or quarterly, anything that we've been dealing with in the last section. So now let's take a look at E. E is very similar to functions that we've seen before. If you recall, if we had x squared times x to the third, that would be x to the fifth, because what do we do with those powers? We add them up. So we have e to the ninth times e to the seventh. Easy enough. E to the 9 plus 7, which is e to the 16th. Okay, so it works the same. So e is kind of like a variable, except it's not a variable. It's actually a number. Remember that e is equal to approximately 2.718. Okay, so just like having a variable there for e, normally if I have, 2x squared cubed, the way that I would look at this type of problem is I would see that we have, of course, this cubed here. I think I'm making it worse. So we have this cubed here. Remember that as long as these are multiplying, I can distribute that cube through. So I really have 2 cubed x to the 6th. If you recall, we multiply those. And why do we multiply them? Because that's really 2 to the first. 3 times 1 is 3. And of course, 3 times 2 is 6. So the same thing over here. So we'd have 3 to the third, e to the 4x times 3. 3 to the third is 27. And we multiply those two powers there. So we have e to the 12x. So that's what we'd have as the final number. Okay, negative 16e to the ninth, 2e to the third, when we have x to the 8th over x cubed. We subtract those powers, so that becomes x to the 5th. So the same thing happens over here. Of course, we do the division here first, so that would be negative 8 e to the 9 minus 3, which is 6. Okay. And we'll do one more. So this particular one is just learning how to graph it, but we don't necessarily have to graph it. I just want to be able to understand some of the other terms. The graphing, of course, you can do on Desmos, but you do need to understand some of the other things. So first off is, what is the domain and range? The domain, anytime we're dealing with an e function, is always going to run from negative infinity to positive infinity. The range In this particular case, remember that this moves down 1, so it's going to start at -1, and it's going to continue up. Notice that it's positive. Since it's positive, it's going to be going up kind of in that direction. So therefore, -1 is the lowest number, less than or equal to x, which is less than infinity. And then we're going to look at the rate of change. So the rate of change gives us some ideas. We're going to look at the graph last. But the rate of change just means we plug in those numbers, -3 and -1, and subtract them. If you remember, the rate of change function is y2 minus y1 over x2 minus x1. And so y2, this would be my x1 and my x2 value. When we write it with square brackets, we're talking about one variable. When we write it with parentheses, we're talking about a point. So I'd plug in the values of x into the equation. So it'd be 4e to the -6, because I plugged in a -3 minus 1. I would do that calculation, and that would be my y1 value. My y2 value would be plug in -1, so I get 4e to the -2 minus 1, plugging these values into this equation here. And that would be my y2 value. Then we have our x1 and our x2, and then figure out what those values are. So now the graph. So what does this function do? First off, we can see that that -1 means that it goes down 1. We know that that means the 4 in front means 4 times faster, so it increases 4 times faster. Okay. We know that it's a growth function. Why is that? Because that's really about 2.72, approximately 2.72 to some power tells me, remember that if it's greater than 1, it's a growth equation. And this 2 means that it stretches out 2 times more. And it's what I mean by stretches 2 times more. It stretches to the right a little bit more. So notice that this 4 and this 2 actually counteract each other, because this one tries to go up faster, and this one stretches out more, so which means it goes up 2 times slower, or half times faster, something like that. So we'd be able to graph that and kind of get a general idea. So of course we know that it moves down 1, so that means that the number down here would be down at 1. It still goes through this point, which is 1 up, but it starts increasing 4 times faster. So it goes up 4 times faster. So normally the function would go up here, it goes up 4 times faster, but then it gets cut down 2 times in half. So it's going to actually be there. So it's going to kind of look like that. It's going to go up like that. So that's going to be the general one. We can go to Desmos and we can graph that and see what it actually looks like. Okay, so that's the end of this video. We'll go do some other problems in the next video.